A confirmation about the audio, please, guys, if the audio is clear and available. Thank you. Satyaranjan, in case there are areas which are not easily to be followed because it is the first session for you, so I would urge you to kindly take a look at the recordings, and along with that, if you revise the recordings, it will be easier to follow. Ankush, what are the doubts? Shelja, we had discussed it in the first class itself. It is roughly around 105 to 110 marks in GS paper 1. And the portion of agriculture which is asked in GS paper 3 also carries around 45 marks. So, roughly, if you combine both of them, then around 150 marks in total can be the one which can be targeted. Bala, it will be started in a couple of months' time. Vikram, by the concept of humidity, we should sweat more as we move to cooler temperature as humidity will be more. No, why do you sweat? Do you start perspiring because of the because of the humidity present? No, you perspire because of the heat. How long does that perspiration remain on your body or on your skin? That is determined by the humidity outside. Right. So when you go to the colder areas, your body is feeling cold. So it won't have any perspiration or any sweat at all. Five times, Ankit. Muskan, in winter, when there is cloudy weather, no dew formation is observed. Why? Because when you have the presence of clouds, these clouds re radiate back the various terrestrial radiation emitted from the Earth's surface that is re radiated back by the clouds. So, if you have these clouds, then they will re radiate back the terrestrial radiation, and that terrestrial radiation will end up reheating the surface again. Okay, and because the surface will get reheated again, that is why the temperature will be high enough and dew formation won't happen. Alfia, to some extent, yes. Sea breeze and onshore winds. So basically, when you talk about a sea breeze, it is a localized phenomena across the coastal area where you have winds moving from a close vicinity of the coastline into the land area. That is the sea breeze. When you talk about, let's suppose, an onshore wind, you have asked about onshore wind. Onshore winds, basically, even sea breeze will come into the slight category of it, but majorly, let's suppose we talk about the trade winds or the westerlies. Now, when they come over to the land, they move over a certain amount of distance, so they have the all the properties, the maritime properties that they could gain, and then they hit over or cross over to the land. So that is basically the case where you can have the difference. However, sea breeze can also be categorized into the onshore category. And Ankush, a difference between Sirocco and Khamsin. Khamsin never ends up reaching the region beyond Mediterranean into Italy. Sirocco does that. Sirocco brings rainfall, precipitation even in the coast of Europe. Khamsin is unable to do so. Khamsin majorly is present only in the region of North Africa. Karthik Raj, how land and sea breeze occur in winter season? By the same property. Even during the winter season, what will happen during the daytime? Throughout the daytime, when you have the sun which is shining, there will be land which will get heated up much faster. Water will take some time to get heated up. So during the daytime, you will have water having a high pressure, land becoming a kind of a low pressure. During night time, water will cool down at a slower rate and land would have cooled down much faster. In winter, land is much colder. So that is where you will have a kind of a land breeze during night time. So again, the same property. Mistral are cold winds. Okay. Is inside respirator have relative humidity? Uh, the respirator machines, is that what you're talking about? It might have moisture. Humidity is the measure. See, humidity is the measure of the amount of moisture present or water vapor present. Inside the respirator, you might have some amount of moisture which is present. It cannot be regarded as a relative humidity. Okay, right. So now we start the discussion from where we left off. So yesterday we had discussed about the formation of the clouds. While ending the session, we had been discussing about the entire process of formation of clouds. Now, in the case of formation of clouds here, what do we observe? We basically observe the fact that, let's suppose, this is the ground surface. Now, air tends to rise up upon getting heated up, or maybe because of a low pressure, there is a convergence of wind. So, the air, whenever it rises up, it tends to cool down along the way. It starts cooling down along the way. As it starts to cool down, basically, as it loses its temperature, thereby it becomes colder and colder and colder. Eventually, when it reaches a particular height where it reaches saturation, that is the relative humidity of 100%. If it cools down even slightly beyond than that, then you will have the kind of condensation. Now, if that temperature where it reaches saturation and further condenses, if that temperature is above the freezing point, it will be in the form of a very cold liquid water droplet. If it is below the freezing point, then you will have water vapor condensing into ice particles. So that is how basically you will have the formation. Now here, eventually these ice particles, they will keep on growing in size till they become very large enough. And when they become large enough, there, these ice particles become so very heavy that they start falling down. Now, as they are falling down, these ice particles will experience a higher temperature. And as a consequence of that, why will they face a higher temperature in the first place? Because as these ice particles, they are falling down, there will be force of friction, and closer to the ground surface there is a higher temperature also, as per the positive lapse rate condition, that closer to the ground surface the air is warmer. As you move higher up, the air becomes cooler and cooler. So as these ice particles, they start falling down, eventually they will start getting warmed up, and that is when they get converted into small liquid water droplets. Due to the heat that they experience, they will get converted into liquid water droplets. And these liquid water droplets is what we experience in the form of rainfall. Having said that, in areas or in conditions where, let's suppose, the ground temperature is below the freezing point, right? If the ground temperature is very low, if let's suppose the ground surface is experiencing a temperature close to freezing point, then what will happen? These raindrops, they might refreeze, and they refreeze into very tiny snow particles, and that is when you experience snowfall. So snowfall is a resultant when the ground temperature or the ground surface temperature is lower than freezing point. So snowfall, when does it occur? when the ground temperature or temperature near the surface is below freezing point. Only then will you experience the refreezing of these raindrops into snowpaths. Now, whenever you associate these with these clouds, basically the clouds can be of varying thickness. They can be formed at different heights as well, because these clouds, the formation is completely dependent on the fact that when is it that the air parcel reaches the point of saturation. And if, let's suppose, the air is very humid, very moist, with a relative humidity of 80%, now in that case, it rises up even 1 or 2 kilometers or 3 kilometers, it can lead to condensation. Or let's suppose the air is very dry, relative humidity of around 40%. It has to rise up quite significantly higher in order to achieve that saturation, and thereby in order to facilitate condensation to happen. So that is why clouds can be formed at various different heights. Now, in the case of the clouds, we oftentimes experience thunder and lightning. We oftentimes experience thunder and lightning. Now, why is it so? That whenever you have a cloud, not every cloud will you experience thunder and lightning to occur. Even if you recall from your memory, when is it that you observed this thunder and lightning event, you would have observed it only in certain cases, only in certain cloud types. So basically, why does this happen? So for this thunder and lightning, you have to understand that on a daily basis, you have hundreds and thousands of lightning and thunder events which occur across the planet. Now, majority of that thunder and lightning occurs in between the clouds themselves, from one region of the cloud to the other region of the cloud. 80% of the overall proportion of thunder and lightning is experienced in between the clouds themselves. Only around 20% of that occurs between cloud and the landmass. So here, 80% of lightning occurs in between clouds themselves. Only around 20% occurs between the cloud and the ground. Only 20% occurs between the cloud and the ground. So here, if you consider the ground surface, or now when you consider these clouds are made up of small particles, many of the small particles. Now, these particles consistently rub against each other, move with respect to each other consistently. These are very tiny particles of ice and dust particles surrounded by ice. In fact, these are made up of multiple and numerous of these tiny particles. Now, these are held aloft, or these are held in the air by the action of the wind movement, or because they are so very light. Now, any kind of wind movement, air movement, etc., can cause a kind of movement amongst these particles here itself. Okay. Now, sometimes what can happen is basically, let's suppose you have one of the particles here on the top, which becomes very heavy due to multiple condensations. As the particles, they keep on rising up, more condensation will happen around them. So let's suppose one of the particles above, they have become very heavy. Now, after that, this particle starts its journey. It starts falling down. The particle, it starts to fall down. Now, as this particle is falling down, and listen to this very carefully, as this particle is going to fall down, it is going to rub against multiple different smaller particles. It is going to consistently rub against multiple of these particles, isn't it? Now, from each of these particles, it will gain some electron maybe. As let's suppose there is this particle, another one starts falling, it rubs against this. Maybe it gains an electron, maybe it loses an electron. Anything can happen, right? So as a result of this multiple rubbing against each other, let's suppose this falling one has gained an electron. So this becomes a surplus electron, negative charge now. Whereas the earlier one, now one electron has left, so it will become positive charge. So as it falls, thereby there is development of charge, positive charge in some places, negative charge in some places, right? So eventually, as this particle begins to fall, here, it will gain negative charge. So all these are small particles of ice, right? So by the time that they fall down, they would have gained enough electrons, they would have gained enough amount of negative charge. Lot of negative charge would have developed. Okay. Lot of negative charge would have developed. Meanwhile, there would have been the particular particle from which these electrons have been robbed away. So there would be positive charges also along the way. Positive charges might also would have developed significantly. Now, when this cloud is big enough, there can be significant amount of these charges developed. Significant amount of these charges would have developed, right? So eventually, charge always flows from either negative to positive, right? Charge always flows from negative to positive or negative to zero. Wherever you have surplus of charge, that means negative. So it flows from negative to zero or negative to positive. So that is why there is a flow of charge associated. So maybe a charge flows like this. Suddenly, rapid movement of charge is experienced. That is when you observe that lightning in the sky. So that lightning which you observe is purely because of the development of charges. Unlike the various different myths which are floated, various different folklore which are floated, that when the clouds collide, that is when the lightning occurs or thunder occurs. It is not like that. It is basically when you have this development of a charge, that is when charges of opposite polarity, you have a sudden movement of great amount of charge to the tunes of thousands of volts and kilovolts. That much amount of charge passes in a very short manner of maybe 1 microsecond or a millisecond. And that huge amount of charge which passes emanates light. And that is what we observe in the form of lightning. Now, sometimes it can also happen. Let's suppose in the ground surface, let's suppose near the ground surface, you have the trees. You have a clearer ground, not much vegetation all around. Let's suppose you have an isolated big tree which is present. Now, ground always represents zero charge or neutral. I hope we are aware of these facts. If we are not, just understand it here. Ground exhibits zero charge. So from negative to zero, charge will flow. So from negative to zero, there will be that flow of charge. And again, you will experience that lightning event. Now, these trees, they are projection of the ground upwards, right? So the lightning will strike the tree. That is why always it is said that regardless of how much rainfall, regardless of how severe the weather, if there are chances of thunder and lightning, the worst place that you can hide is underneath a tree. And particularly if that is the tallest tree in the region or the most densest tree in the region, and all around it you have small shrubs, chances are lightning will fall on that. Now all the people basically standing underneath them, they will experience such high amount of movement of charge, and that too in a short time period. You are talking about kilovolts of charge, or the amount of voltage passing through your body. Even if, let's suppose, your body experiences an electric current higher than 15 milliamperes, it has got enough potential to stop the beating of your heart. It can cause heart attack. But in this case, you have such a huge amount of charge passing through the body, along with the heat, the body simply burns off. That is why every year in our country, we experience casualties of hundreds of people due to lightning events. And particularly in the region of the farmlands, fields, etc., where you will have these kind of features like an isolated tree, or if everybody has taken shelter underneath a larger tree, etc., that is where they get impacted by this. Okay, so the prime reason of lightning is the development of charges and the flow of charge from negative to zero or negative to positive. But why does thunder happen? Lightning occurs because of flow of charge. But why do we experience thunder? That rumbling noise which emanates almost immediately after lightning, why do we experience that? So there is a reason for that also. So for example, when we talk about, let's suppose the air here, in this portion, in this entire portion, let's consider the air in this region, where in the vicinity where lightning has occurred. Now, as lightning has occurred here, there will be sudden rise in temperature in this area. There will be a kind of a sudden rise in temperature in this area. Now, as the temperature rises suddenly here, what happens to air when it gets heated up? It tends to expand. Here, the air, for that transitory moment, for that temporary duration, air might be experiencing a temperature in hundreds of degrees Celsius. For that brief millisecond or microsecond, air might be experiencing a temperature crossing 100 degrees Celsius and more. So, what will happen here when suddenly so much amount of heat is supplied? The air expands, but expands violently. And when that violent expansion of air is observed, that is when you hear the rumble of a thunder. So here, basically, due to sudden immense heat. The air gets heated up very significantly and experiences a sudden, violent expansion. That sudden, violent expansion which occurs creates the rumbling noise, and that rumbling noise we experience as thunder. So that is what we have as thunder. Okay. So basically, again, what happens? You have the particles. Let's suppose the particles on top, they become heavier and the cloud is so thick enough. So these top particles, they will start falling. As they fall, they will rub against multiple other ones. As they keep on rubbing against with a kind of a force, they will gain an electron from the other particles along the way. So the falling particle would have gained electrons, and by the time that it reaches the end or the lower portion, it would have gained electrons and would represent a negative charge. Meanwhile, the other particles against which it has rubbed against, they would have lost an electron and they will exhibit a kind of a positive charge. So because of these rubbing of particles, there is development of positive and negative charges, and that is when you have significant amount of flow from negative to positive or negative to neutral, and that is what we experience in the form of lightning events. Okay. Why lightning not occurs in cities? Who told you lightning doesn't occur in cities? Lightning very frequently occurs in cities also. In very tall buildings, in those areas where you have tall buildings, lightning oftentimes strikes them. That is why the buildings have lightning conductors installed, where the excess charge or that excess amount of flow of charge is immediately directed to the ground without impacting the structure of the building. Okay, right? Heat the air. It is air written there. Where is air written there? Sudden events heat, the air gets heated up very significantly and experiences. Where, Nikat? It is correct. Can lightning cause landslides by striking the ground? Not generally, but then when you have such huge amount of energy which passes through, it can have some impact on the ground surface. But sometimes it can bring about avalanches. For example, the very loose kept snow that starts falling and eventually it brings a degree of avalanche. That can happen, but not what you see in the movies that the god basically looked down there. There was this god of lightning, Zeus. He looked down, there was lightning, and eventually the entire planet collapsed. Such things don't generally happen, but it can have some potential to create some disturbance. Okay. Lightning occurs even in plane surfaces. Why won't it occur? It can occur even in plane areas. Sometimes even in plane regions, because if there you have lot of negative charge there, and ground surface represents zero charge or neutral charge, so that is why basically it can fall on the plane surface also. How hailstorms occur, we'll come to that. If sir thunder was happened, then sir why another house some electric portion gets destroyed? Electric portion gets destroyed because of that sudden flow of charge, that sudden excess flow of charge, which can power electrical trains also. So electric engines also, it can power that huge amount of charge we are talking about. Obviously, the household circuits and the fuses, they are nowhere close to being capable enough to handle that much amount of flow of charge. So that is why everything short circuits. If that, let's suppose, lightning falls upon a transformer or a series of wires, there can be power outage in the entire area. Okay, right. Now, after this, we move ahead to the types of clouds. When we talk about the types of clouds, there is a classification of clouds based upon the height, the altitude on which they are to be found. Now, these particular clouds, there are various different types of clouds here. Now, you have low level clouds, you have high level clouds, you have mid level clouds, and you have clouds which are spread across multiple different layers also. But basically, I don't want you to learn all of this or rote learn all of this. I want you to understand this so that you are able to reproduce these types of clouds from your memory whenever you want. So basically, clouds are classified based upon their shapes also. So, first of all, you have a category of cloud, which is the cirrus cloud. Cirrus basically is high altitude, feathery clouds. For example, observe this one. These kind of clouds that you see, which are not nowhere dense enough, you can basically see the sun rays also. This is where the sun rays provide that yellowish color early in the morning, late in the evening. So these kind of clouds are formed at very high altitude. There the condensation would have happened right up till the region of tropopause. So these are clouds which are formed at an elevation of 10 kilometers and beyond. You can't experience rainfall in these cases, because even if, let's suppose, those ice particles will fall, by the time that they cover 10 kilometers, they would have experienced enough heat to melt and re-evaporate back again. So that is why cirrus clouds are rarely associated with any form of precipitation. Then you have a kind of a cloud type. That is what is known as basically stratus. Stratus is a term derived from strata, meaning layers. So when we talk about stratus, it talks about the clouds in layers. So generally, you would have seen sometimes clouds which are spread over a large area. They appear whitish, not a complete white, but not black or dark as well. So these are very large, layered clouds, very large layered. Now, ideally, when you have these stratus clouds close to the ground surface, now the low level stratus cloud, if they are there, then you experience very light rain. If you associate with rainfall for a brief moment, you will be able to recall that all the rainfall types are not the same. Sometimes you will have very large drops falling, very heavy amount of rainfall falling, where even stepping out for 5 seconds will mean that basically you will get drenched through and through. So that heavy kind of a rainfall, that is one category. Then sometimes you will observe mild, moderate rainfall, which continues for hours altogether. It has started raining at 3 p.m. It is continuing to rain at 8 p.m. also. Mild, moderate rainfall. Sometimes you observe very light, thin drops of drizzle, very thin drops of water falling, where you can even walk out. Generally, people, they do go out, but then you experience those very tiny drops falling on your face, on your skin, right? That is the drizzle. So stratus clouds are generally associated with that drizzle, very light amount of rainfall happening for some continuous amount of duration, and it will dampen the road, it will dampen the surface, but you won't experience that heavy downpour. So that is associated with the stratus clouds. Then you have cumulus. Cumulus. This is derived from the name accumulation. So here you have certain cloud types which appear like heaped up balls of cotton, right? That is what is cumulus, where you have heaped up formation. So these cumulus clouds generally are resultant of the rising air column and then condensation happening at different heights. That is why there is a kind of a vertical development in these clouds. Stratus clouds, they are not thick vertically, they are horizontally distributed, very large horizontal distribution that you will observe in the clouds sometimes. Right? Sometimes you would have seen that you have that whitish cloud cover, the blue sky is not visible, but it is whitish cloud all across. It appears as a white ceiling almost, which there is a layer of cloud spread over a large distance. So that is your stratus cloud. Then you have the nimbus cloud. That is another type. Nimbus is basically the rain bearing cloud, which will bring you heavy rains. Rain bearing clouds. Now, when we talk about these clouds, these particular cloud types, wherever they are found, they are named accordingly. High altitude clouds, if they are formed in the shape that I have shown you, they are known as cirrus. If at high altitude, they are found in stratus formation or a layer formation, you attach the prefix cirro. So cirrostratus or cirrocumulus. Then at middle altitude, at a height of around 3 to 6 kilometers, you attach the prefix alto. So it can be altostratus or altocumulus. Then you have low level clouds. Low level clouds, stratus, cumulus, or you can have a combination of these two. What is stratocumulus? Stratocumulus will have a mixture of these. So it will be having a very large horizontal distribution, but in certain places you will also have vertical distribution. This is stratocumulus, flattish base having a horizontal and vertical development. So a cumulus cloud within the stratus layer, that is what is stratocumulus. Then the rain bearing ones, which will bring you heavy rain. Now understand, stratus, cumulus and stratocumulus can also bring you rainfall, but not in great quantity. Larger and heavier rainfall that you experience is caused by these two, cumulonimbus and nimbostratus. Cumulonimbus means it is a rain-bearing cumulus cloud. It can be multi-layered. It can start formation of this. You can start observe the start of these clouds maybe 2 kilometers from the surface, extending up till 12 kilometers up into the sky. Right? So these clouds can be 6 kilometers, 8 kilometers, even 10 kilometers thick. So imagine if you have a 10-kilometer thick cloud, how much charge will develop because of the particle movement. Huge. Continuous melting, condensation will be a part in that cloud. That is why cumulonimbus is associated with very heavy, violent rainfall, where you can't even step outside for a few minutes. Heavy, violent rainfall associated with lot of lightning, lot of thunderstorms, but that rainfall lasts only for a short duration. You would have experienced that when it is a very heavy rain, it will last maybe for 1 hour, maybe 1.5 hours, right? Not more than that. Then it will be moderate rain, less amount but continuous rainfall. So that is created by nimbostratus. Okay, so rather than rote learning all of these clouds, just understand what is cirrus, high level, high altitude. What is stratus? a kind of a horizontal layering. What is cumulus? Accumulations in different areas, right? So you have the case of cirrostratus, cirrocumulus, cirrus in itself, then altostratus, altocumulus, then cumulus, stratus, stratocumulus, and then nimbostratus and cumulonimbus. These are the various different cloud types. Okay, so here, if you observe, basically, this is the schematics for it. So here you have cirrocumulus, cirrostratus, and cirrus. So these are very high elevation clouds. Very rarely will you experience any kind of a rainfall being caused by them, or any precipitation caused by them. Then mid layer, if it is layered format, altostratus. If it is in a accumulation format, altocumulus. Low layer, cumulus can cause short bursts of rainfall. Stratus can cause very light drizzle, which can continue for a very long time. Stratocumulus is a mixture of both, can cause significant amount of precipitation. Nimbostratus, it can include within itself some amount of cumulonimbus. You can think about it that within the nimbostratus also there can be cumulonimbus, right? Then the cumulonimbus, the most violent of them all. So few of these basic cloud types I will give you an idea about. So here, when we talk about the cirrus clouds, they are feathery, wispy formations made up of very minute ice crystals. This is a cirrus cloud. Now here, they are not even thick enough to block the movement of sunlight, right? So they are basically almost transparent, if you can think about it. So that is why the rainbow formation, etc., that you observe, along with that, you will observe that the sun, when it shines through these clouds, you will be able to observe that kind of a lining around the sun, the halo around the sun and the moon is something that you will be able to observe. When the sun basically early in the morning starts rising up, you will observe that some cloud types, they get lighted up into bright orange and yellow. And even during the sunset, some of the cloud types, they get lighted as bright orange, red, and yellow, yellowish almost. That is the cirrus cloud. By the refraction of light, that is how they are exhibiting these. So these are very high level or high altitude clouds. They are often colored in bright yellow or red before sunrise and after sunset. They light up long before the other clouds and fade out much later during the sunrise and sunset. They rarely bring condensation, rarely cause condensation. Okay, then cumulus cloud, if you observe, these are your cumulus clouds, heaped up. There's a vertical development. There's a vertical development in this cloud. That means air is condensing at various elevations. That is why there's a kind of a vertical development which happens. Now, it is thick, low altitude cloud, usually puffy and has got a vertical development. They looked like heaped up cotton and found everywhere in the world except for the polar areas. Other than the polar regions, they are to be found everywhere in the world. Caused primarily due to evaporation. Wherever there is evaporation, you will always associate some or the other cumulus cloud. Even now, if you step outside your house, you will observe some of these cumulus formations, right? Some small patches here or there. So I urge you, at least tomorrow, do step outside and do observe the sky. Observe these various different kinds of formations and observe that all the clouds do not appear to be at the same level. Next time when you fly from region A to region B, you will observe that there are various different levels of cloud formation, right? You have a layer of clouds at a height of around 3 to 4 kilometers, and then another layer of clouds at around 8 to 9 kilometers, right? In between, there might be absolutely clear conditions. So that is where, wherever condensation happens, at whichever temperature and whichever height the condensation happens, that determines the clouds. Stratus, They indicate a kind of a rainy weather composed of thin layers of clouds covering a large area. They cause light, mist, or drizzle, continued for some time, continued for considerable period. No heavy rains. This cloud is not associated with heavy rains. The ones which are associated with heavy rains, for example, nimbostratus. Now, here, by the way, many of the times you would have seen that clouds in certain areas they appear of a different color. Here they can appear black, here they can appear whitish. Why is it so? Why do you think the clouds have this different appearance? Can you think about it? Yes, very good. It is how much amount of sunlight is blocked or how much amount of sunlight passes through. Okay, so basically when you have this amount of sunlight here, if the cloud is, let's suppose in a region the cloud is thin and then gets very very thick, again gets very very thin, so from the thinner portion sunlight will pass through, and then the thicker areas the sunlight might not pass through. So these areas will appear brighter, these regions will appear darker. The sunlight will be reflected back from the cloud surface itself. So that is how, or that is why, the clouds exhibit different coloration. Now, nimbostratus is associated with a continued rainfall, moderate intensity, but continued rainfall. Where it has started raining from 11 a.m. in the morning, it is raining till 11 p.m. at night. It is not very heavy, but it's still significantly strong enough that you don't venture out. So that kind of a gloomy rainfall condition that you observe, that is associated with nimbostratus, right? So here they are low clouds and they are actually multi-layered. Their vertical extent might go into the alto region also, or the mid region also, and they often have taller cumulonimbus clouds embedded within them. So in the case of nimbostratus, you also experience lightning. In centers where they are very dark, you might have lightning from surface or from the cloud to the ground surface, but mostly in nimbostratus, you observe lightning in between the clouds also. Okay, from one portion of the clouds to the other. So always understand, whenever you observe in the sky a continuous cloud formation for a very large distance, there of different coloration, etc., if it will rain, it will rain for a very long time, right? So wherever you have to go, do move, because if it is starting to rain, it is going to rain for a very long time. Then you have the most violent of all of them, and that is cumulonimbus. Cumulonimbus is the one, many of the times you observe it late in the evenings or late in the afternoons, early evening, around 4 p.m., 5 p.m. Suddenly it becomes dark. The sunlight faintly shines through, making some areas of the cloud yellowish. The rest of the region is absolutely pitch black or dark. I hope you can recall such kind of a cloudy condition. And then, when it covers an area or your region, it almost blocks the sunlight completely. It brings with it thunder, lightning, and very heavy amount of rainfall, generally associated with the movement of winds also. So windy conditions, very heavy amount of rainfall. So when you observe these kind of cloud formations, understand it is going to rain very heavily, but that heavy bout of rainfall is going to last at max for 1 hour or 1.5 hours. After that, the rainfall intensity will reduce. If not, it will stop. right? Because of such great vertical development, that is why it is always associated with lightning and thunderstorms. That is why, in the case where you observe these kind of cloud formations, advisable, take some precautions. Don't step out. Step out after 1.5 hours when everything has basically dropped and it is moderate rainfall. If you have a nimbus stratus, then it is going to rain for a very long time. Okay, so that is how, just by appearance sake also, you can end up making out which kind of cloud formation are we talking about, and which kind of cloud will have which kind of properties. Storms, for example, cyclones, always associated with cumulonimbus clouds. Okay, now after this, can cumulonimbus be formed due to volcanic eruption? Whenever there is a volcanic eruption or whenever there is a forest fire, in both these events, there's a significant amount of very thick cloud formation. In the case of volcanic eruption, sometimes the clouds, along with the ash, that can extend even up till to the top of stratosphere. For example, when you had the Tonga eruption, which occurred in January 2022, the cloud went up till the level of mesosphere. So, during the volcanic eruption, you will have significant amount of water vapor which comes out from the vent. You have so much amount of dust particles which are emanated. Now, this water vapor, as it is thrown up due to the volcano, it will start rising up. It will cool down immediately. Cool down, condense at multiple layers wherever the dust particles are present. So, you have a dense cloud. Same is the case with the forest fire also. You have very dense cloud. Now, will there be lightning events in the case of the volcanic clouds? Or will those clouds not experience lightning events? What do you think? When we talk about these volcanic clouds, there will be some of the maximum density of lightning observed, where in the same place, multiple times these lightning strikes will continue to happen. Hundreds and thousands of lightning strikes are recorded in the same place within the period of 4 to 5 days, if the volcanic eruption has been strong enough. Why is that? Because you have so many dust particles, so many condensates, they will be rubbing against each other continuously because the volcanic gases are rising up, some of the ice particles are falling down. That creates that charge exchange. Such kinds of clouds form during the volcanic eruption and form during the forest fires. They are known as pyrocumulonimbus. That is what is the name associated with those kind of clouds, which can impact even the region of stratosphere many of the times. Okay, right? So it is not as if cumulonimbus will have less rainfall. All that rainfall will be concentrated in a short time duration. Nimbostratus, it is distributed rainfall spread over a large time. Okay. Why sometimes rain occurs during daytime even though it is clear sky? Observe carefully. There must be some cloud somewhere. It cannot happen that if it is absolute clear sky and if it is starting to rain, then you have to look at it with some amount of suspicion, significant amount of suspicion. Something wrong. Maybe you are not able to see the cloud which is on the other side of your house. Maybe that can happen. But there cannot, can you can never fathom a situation where there is no cloud at all and it is still raining. Okay? Now, what if one cloud hit the other cloud? Are they like cars and buses? When you think about the clouds, do you think they are cars and buses? I hope you are aware that through these clouds, if let's suppose you go for skydiving and if the clouds come, what do you think will happen? Will you bounce out from the clouds into the moon like you saw in the cartoon movies of the younger days? Do you think that will happen? That you are falling on the clouds, you will bounce back up and go back up? You'll be able to fall through. Similarly, when you have two different clouds, they come together, they will merge. They can become thicker, right? Cyclones happen due to cumulonimbus or nimbostratus. Cyclones happen because of low pressure. Cumulonimbus or nimbostratus clouds are formed depending upon what kind of cyclones are we talking about. I once saw a situation where the front of a building there was heavy rains on the backside. Yes, that can always happen. That can always happen, that in one area you have rainfall and next to it, for example, if you go to the region of Western Ghats, you will very frequently observe the scenario where from the hills you can observe the rain coming, and it takes some time to reach you, so you can observe that coverage of rainfall. So that basically happens. Okay. Aeroplanes travel during rainfall, absolutely yes. In some situations, there's formation of thick, dark colored clouds, but they do not precipitate. So formation of clouds in itself does not mean it will rain. Formation of nimbostratus also does not mean it will rain. It can rain. So when it is about to rain, when will it start raining? When you observe sudden dampness in the air. Let's suppose if you are sweating, it doesn't evaporate anymore. Suddenly, there is that warm condition around, right? Or if sudden cooling or change in temperature is there. But mostly in the afternoons, if you feel the air around you is almost stagnant, it is not moving at all, there is going to be rainfall, because that means relative humidity in that region has reached close to around 80-90%, which is sufficient to bring you condensation from above. Now, here, they produce lightning, thunder, heavy rain, hail, strong winds, and tornadoes. The tallest amongst all the clouds, they can span all cloud layers and extend from 2 kilometers right above. Then it can be seen most commonly during the afternoons of summer and spring. When the Earth's surface releases heat, there is evaporation and then condensation, which occurs at different heights. So, as the condensation does happen at different heights, there is a kind of cloud formation which will occur at different heights. Okay. If aeroplane is trespassing through cloud, it can also build charge and burst. Up till build charge, it was fine. But why will it burst? If you have too much development of charge, why will it burst? So it won't burst. So airplanes, that is why when airplanes, they land, whenever they land, airplanes, generally on their surface there is high development of charge, very high amount of charge. That is why when the airplane lands, there is a grounding. uh, in case a thick metallic wire or a metallic piece from the airplane body is made to touch the ground before everybody starts to deplane. So that acts as a conduit for whatever charge is developed across the body to flow in. But if you have the doubt that charges will develop on an airplane, yes or no? Absolutely yes. It develops a charge as it flies. But will that charge influence the passengers inside? Absolutely not. There it follows a principle of physics, what we refer to as the Gauss law. We should not go into the details of Gauss law, because then we are talking completely about physics and charges. Gauss law basically tells that if you have a hollow object, a solid metallic hollow object, the charge continues to remain on the outside, the interior portion is protected. It is the same principle which makes a moving vehicle, a moving car, or a moving bus the safest mode of transportation during the event of a lightning. All the charge will be accumulated on the outside unless and until you are touching the surface from outside. All the charge will be restricted in the outside. Inside, it will be safe. Ankush, I had basically answered your question. Again, I will answer the same question. Kindly listen to it carefully. Cyclones are not formed because of cumulonimbus or nimbostratus. Cyclones are created due to low pressure conditions on the ground surface. It is during that low pressure condition that sometimes you can have cumulonimbus. In certain cases, you can have nimbostratus, depending upon the type of cyclone that you are talking about. We will discuss when we talk about cyclones. Okay. Yes, Rabia, obviously, yes. I will be answering to you in English if that is fine with you, right? Again, I will tell you, it is not the case that cumulonimbus can cause rainfall. It is not the case that cumulonimbus can cause tornadoes. It is during these events that you can observe the cumulonimbus clouds to be in existence. Okay. Now, coming to the final question, Lekhani. In volcanic eruptions, from where does the water from the vapor come to form a huge cloud? Is it the gases from inside the earth, including vapor? Take a look at the PPT that we have discussed during volcanic eruption. We have mentioned there that one of the most dominant gases which are ejected during a volcanic eruption is water vapor. Water vapor or steam is the most dominant gas which is released. Okay, so now we come to the phenomena that is known as cloud burst. Now, this cloud burst basically is experienced in certain areas, and the image in itself is self descriptive. Cloud burst, where the cloud is unable to hold itself together anymore and it simply gives way. Everything which is contained there, all the condensates, they start pouring down. It is as if somebody has appended the cloud and everything starts falling down in the same region in the same region in a very concentrated time period, in a very small time period, in a very small duration, in the same area, you have that excess amount of rainfall which occurs. So that is the cloud burst. Now, when we talk about a cloud burst, you will here observe this. The cloud has become unsustainably large. Everything has started falling. So, why will the cloud become so unsustainably large? Isn't it that when the cloud starts becoming larger, there itself it should start bringing rainfall? Why is it that the clouds will become so unsustainably large? Due to the movement of winds. So cloud bursts, they basically, yes, that is the rain falling. So it is a localized but intense rainfall activity. Rainfall of 10 centimeter or more in an hour over a 10 by 10 area, 10 kilometer by 10 kilometer area, you have 10 centimeter of rainfall. In case you are unable to fathom whether 10 centimeter of rainfall is high or low, let me tell you, annual amount of rainfall in many portions of Punjab, the annual rainfall is around 60 to 70 centimeters. So think about it, in 1 hour, if you are receiving 10 centimeters or more of rainfall, you can imagine the intensity of rain. It will always immediately bring flash floods. Flash floods are what? Sudden occurrence of floods, where the small streams, the rivers, etc., due to such huge amount of sudden water supply, they will start overflowing. There can be landslides, which happen if these cloudbursts occur in hilly areas. For example, this year, in the month of July, in the month of August, the landslides which were initiated in the region of Himachal Pradesh were instigated because of that cloudburst. If you take a look back at 10 and a half years ago, when you had the Kedarnath disaster, which claimed the lives of more than 20,000 people easily. Now, that Kedarnath disaster was also instigated by the cloudburst. So, cloudbursts, they majorly occur in hilly areas. Sometimes, however, very rarely, but sometimes, they can occur in the plain regions also. Okay, so cloudbursts majorly majorly occur in hilly regions. Rarely, but sometimes it can happen even in plain areas. Now, why does it occur? Because the clouds grow unsustainably large, unable to hold its weight. But why will the clouds become unsustainably large? Can't it be the case that as soon as the clouds start becoming heavier, they will bring rainfall? Again, let the new cloud formation take place. Again, when they will become heavier, they will bring rainfall. Why is it that the cloud is allowed to become unsustainably large? So let us consider the hilly areas first. Let us consider that. Let's suppose you consider a mountainous or a hilly region. Now, during the monsoon months, or let me use the image somewhere else. This is a cumulonimbus, yes. This is a cumulonimbus cloud. Cloud bursts, whenever they occur, there will be cumulonimbus. Why? Because of the formation. So understand. Now let's suppose this is a mountainous or a hilly area. Now here, as the winds they start to blow, let's suppose during the monsoon season, the winds are moist, some amount of water vapor is there. Now, as these winds come over across the windward side, this will be the windward side of the mountain. I hope we can revise that portion. Windward side. So, the rainier side. This is your leeward side, the dry side. Now, here, as these winds they start to rise up, excuse me, as these winds they start to rise up, they will cool down. Now, eventually, they will reach saturation. They will cool down beyond the point of saturation. And what will happen? Condensation will happen. There will be cloud formation. Let's suppose there is a cloud formation. Yeah. Now, this wind is a continuous one. It is not as if one band of wind has come and now it is calm again. It is a continuous movement. So, what does will this continuous movement do? It will keep the cloud afloat. This wind movement will keep the cloud afloat. Right? It will not allow anything to fall down. It will keep it afloat. And more winds are coming in, more winds are rising up. So, what will happen? More condensation will happen. More condensation will happen. The existing cloud will grow larger. Then, after this, what will happen? Much more condensation will occur. This cloud will grow further larger as more winds are coming. Eventually, what have you attained? An unsustainably large cloud, very heavy, unable to hold its weight. Now, you can think about it as a cluster of many of the cumulonimbus formations. Let's suppose, for a brief moment, maybe of a couple of hours, maybe of a half a day, maybe one day, for a brief moment, if the wind becomes discontinuous, Now, there is no such force to keep this large formation afloat. There is no such additional force which will keep this heaped up amount of ice afloat. It is very heavy now. It will give way. Immediately, it will give way. And everything that it contained, huge amount of it, raindrops, rainfall, in huge quantities, will be observed to be concentrated in this very, very small area. And that event, where the rainfall in that area over a period of 1 hour is more than 10 centimeters, that is what we refer to as an event of cloudburst. It can lead to landslides, it can lead to flash floods, it can lead to any such events. That is why during the monsoon months, when you have these moist winds, they almost blow permanently in the fixed direction. They will create these conditions. And in the monsoon months, you have events of cloudburst in the region of Western Ghats also. You have events of cloudburst almost definitely every year in the region of Himalayas also, particularly in the region of Himachal, Uttarakhand, Sikkim. You will observe a lot of these cloudbursts. Even in the northeastern hills, the Purvanchal, you will observe these. So that is what is associated with the portion of cloudburst. Okay. Now, that is about the hilly areas. Sometimes, rarely, it can occur even in plain areas. Now, in the plain region, why will it happen? So, in the plain area, let's suppose there is low pressure on the ground. Winds will come, they will rise up. Let's suppose the winds also get heated up around this low pressure. It is a thermal. If it is a thermal low pressure, it can be any kind of a low pressure. But let's suppose the winds here in the region of low pressure, you have a rising air column. So let's suppose low pressure will attract more winds. Always the winds blow from a high to a low. So low pressure will be the attraction point of the winds. They will attract more winds. More winds will come. They will get either heated up or pushed up. So they start rising up. Now there will be convection. Eventually, the same process can happen if it is a moist wind. The same process can happen that you can have an unsustainably large cloud formation kept afloat just by this rising wind. Eventually, it might give way. As soon as the wind stops, everything might give way, and you might have excessive amount of rainfall in the form of cloudburst. So that is how these cloudbursts do occur. Sometimes you will observe these events spanning across for maybe 2 hours, 3 hours also sometimes. That causes absolute devastation, 1 hour. So that is something which you experience in this case. Okay. Now, then if man is under where there is cloudburst, you will experience significant amount of rainfall, very heavy amount of rainfall. It does occur in the habitation areas also, particularly if you get an opportunity to visit the region of Western Ghats and the southern portion of Western Ghats in particular, around Kerala, the portions of Karnataka and the Nilgiris. You will, if you are on top of any of these hills, you will be able to observe these events very easily in the nearby vicinity. Somewhere or the other, these events are triggered very frequently during the rainy season. So that is basically the case of cloudburst. What is the leeward side? The opposite of the opposite side where the wind is coming, the opposite side of it is known as the leeward side. We have discussed it when we were talking about the Chinook. Why so much amount of wind? How sometimes wind is too speedy that occur the fall of trees. Wind velocity Twisha is controlled by what? The pressure gradient force. If the low pressure is very low, high pressure is very high, wind speed will be very high. Why so much amount of wind? For example, the permanent winds, they continue to blow throughout the year. So wind circulation is always initiated by the pressure difference. which cloud forms? Generally, during this, you have cumulonimbus cloud formation. Now, then we come to another of these events, which causes significant amount of disturbance on the ground surface, and that is the hailstorm. Now, many of the times you would have experienced in your place also that you don't have temperature which is low enough to cause snowfall, but there are large chunks of ice which fall down from the sky, mostly during late afternoons, right? During the summer season. That is when you have chunks of ice falling from the sky. And people very liberally, they call it that today my region experienced snowfall. Today my region is better than Shimla and Manali because there you have to travel. In my region, there is natural snowfall. It is not snowfall. These are very large chunks of ice, and these have got the snowflakes. Wherever you have snowfall, you have very tiny particles of snow which almost shower down upon you. But when you have these hailstorms, you have these large chunks of the size of a golf ball, even. They fall down with a great force. They can break the windows, uh, the glass protective shields, etc., the glass shields of your vehicles. Everything can be broken. It can cause casualties also. If you have this large chunk falling upon the head, it sometimes can cause very significant injuries. So, why does this hailstorm occur? Hailstorm doesn't occur anywhere and everywhere. For the hailstorm to occur, you need two primary conditions to be fulfilled. One of the condition is presence of very thick cumulonimbus cloud formation, whose vertical development is very high. So presence of a kind of a very thick cumulonimbus cloud. Then other than that, you will have another condition, very strong low pressure on the ground, which creates intense vertical movement movement of air, what is also referred to as updraft of wind. So these two are the conditions which are required. Only in these cases will you experience these hailstorms. Now, what happens? So let's suppose you consider the ground surface. Now, let's suppose over the ground surface you have a cumulonimbus cloud formation, a thick and a dense cumulonimbus cloud. Let's suppose. Now, on the ground surface, if there is a very intense low pressure, very strong low pressure, it can be due to heating, it can be due to a traveling low pressure. For example, mostly you will experience this in whichever part of the country you are in. You would have experienced these hailstorm events during either late May, June, July. Unless and until you are in the region around, let's suppose, Delhi, some portions of Haryana, some areas of Punjab, Western UP, you could have experienced this, or even northern Rajasthan. You would have experienced this phenomena sometimes even in December. But that has nothing to do with temperature. It is a traveling low pressure system. A low pressure system travels through the northern part of the country during these months. That is why you would have experienced. So there needs to be a very intense low pressure. Now, Most of you would have experienced this during the summer, and you would have experienced that it does not occur around 12 or 11 a.m. in the morning. It does not occur around 1 p.m. After the ground has been heated throughout the day, so that a significantly strong thermal low pressure has built up on the ground, then you will observe that this cumulonimbus cloud, which covers the entire area with darkness, there's a very strong wind motion. Stormy winds, like you were asking that why sometimes the winds are so strong that it can pick particles and move away. Very strong winds. Why? Because the low pressure is so intense. So when the low pressure is very intense, what will it do? It will attract the winds from all different directions. And these winds, they will then rise up. Stronger low pressure means there's a very strong vertical rise of the wind, right? These winds, maybe they also get heated up around this region of low pressure because the ground is so very heated up. So we are talking about, when we talk about this low pressure, we are talking about the area maybe to the size of a large city, right? That is the area that we are talking about. So here, the air also might get heated up. It also starts rising up. Now it rises up. Now, meanwhile, already there is a dense cumulonimbus cloud, very dense cumulonimbus cloud. Now, in this dense cumulonimbus cloud, let's suppose an ice particle has become slightly larger and heavier enough that it starts to fall. Eventually, it is this ice particle which will then melt to cause rainfall. Now, this ice particle starts to fall. But as this ice particle starts to fall, it experiences this strong updraft. So what it does, this updraft, what it does, it sends the ice particle back up. It will refreeze. It will refreeze, will accumulate any amount of condensation around it. It will grow slightly larger in size. More condensation will start happening around it. It will grow larger in size. Again, by the time it reaches the top, the winds would not have that much impact on the top of the cumulonimbus cloud. So again, because it is heavy, it starts to drop down. It starts to drop down, accumulating and converting into ice any liquid droplets that it finds nearby, carrying out condensation of any particle that it finds nearby. And then it starts to fall. But again, as it starts to fall, it experiences this strong wind movement. And that wind again pushes it upwards. Again, it will refreeze. Like this, a repetition of this process makes this particle larger and eventually much larger in size. The size continues to grow. Every time that it goes up, every time that there is condensation, the size will continue to grow because more particles, it will move against more particles, it will start accumulating more of the ice droplets, and like that, eventually it will become so large and so heavy that now even these winds cannot hold it anymore. The winds won't be able to provide resistance to it anymore. And that is when it drops. As it drops, the outer portion of it starts to melt, but because the particle size is so large, it falls in the form of chunks. These chunks of ice, They are known as hailstones. These are known as hailstones. Right? And this entire event is known as a hailstorm. That is why these hailstorms are always associated with a very strong and a heavy wind movement. Why? Because these winds are getting attracted towards that region of low pressure. And there is that strong vertical updraft or vertical upward movement. And that keeps on pushing these particles up again. They fall, they melt, again they are pushed up, they recondense, they refreeze. Every time this process happens, their size keeps on increasing. Eventually, they become so very large that they cannot be held up anymore, and then they start to fall. Okay, right? I hope that is understood. Why is hailstorm not formed all the time in the cumulonimbus? If it does not happen daily or on weekly basis, okay. So most of you want it happening on a daily basis. So on a daily basis, first of all, you don't observe cumulonimbus. And if the question is why every time in the case of cumulonimbus it is not formed, understand the key property here for the formation of hailstorm is not the uh, only the cumulonimbus cloud. You need that updraft movement of the wind. If the strong updraft is not there, you will not have that multiple refreezing exercise. That is why it is not going to be consistent. Only when you have intense or acute low pressure developed on the ground surface, which in itself is a very rare scenario, that is when you will experience this vertical updraft, and that is when the hailstorms occur. Okay? What if any plane blows through these clouds when the ice chunks are almost at the time to fall? It is not as if these are so very large ice. So, or what you are trying to fathom is, will there be a plane crash or not? So generally the planes avoid these thick clouds. They have the Doppler radars so where they can avoid these. But if you have traveled during the rain, now it is a turbulent flight when it moves through the clouds because of the movement of the air. But if let's suppose it is a very stormy or a rainy cloud where lightning, etc., you can see from the window panes and the window screens, there you will observe the slight clinkering noise as the plane passes through the clouds. You will observe, if you have noticed, you will observe that slight clinkering noise as if you have certain particles hitting against the metal. So it is basically the various different particles, the ice particles, they simply keep on hitting against the plane as it moves through. But a small chunk there, it would have, if you are talking about that region of the plane, by the time that the plane is flying there, the chunk of ice would not have gained enough speed by that point of time to mortally destroy a plane for that matter. Okay, right? Now, let us take this question. So, the question is, which one of the following statements is correct? Cirrus clouds are composed of ice crystals. Cirrus clouds have a flat base and appear as rising domes. Cumulus clouds are white and thin and form delicate patches and give a fibrous and feathery appearance. Cumulus clouds are classified as high level clouds. Simran, it can always destroy crops. Yes, hailstorms can always, even cloudburst and hailstorms, both of them they do always destroy crops. Lot of post harvest losses are attributed to hailstorms. Okay, so equal distribution I see in case of wrong and correct answer. Cirrus clouds are composed of ice crystals. How many of you think this is incorrect? Please let me know. All those who have marked the different ones, why do you think that cirrus clouds will not be composed of ice crystals? What is the reason? So, what will the cirrus clouds be composed of? These are high altitude clouds at a height of around 10 to 12 kilometers if the condensation is happening. So, the temperature you are talking about will be in the range of -10, -20, -30 degrees Celsius. So, there, cirrus clouds will be composed of what? I want to understand what is the point of view in that case. What will the cirrus clouds be composed of? They would be composed of something? No. Water cannot remain in liquid state at that height. So this is correct, the first statement. But let us take a look at the other statements, why you have marked it incorrect. So cirrus clouds have a flat base and appear as rising domes. Which cloud has got a flat base and appear as rising domes? It is stratocumulus. Cumulus, which has got a flat base and appear as rising domes. Cumulus clouds are white and thin and form delicate patches and give a fibrous and a feathery appearance. Which clouds give you this kind of an appearance? Very feathery, fibrous appearance. Very good. It is going to be the cirrus clouds. Then cumulus clouds are classified as high clouds. Is that correct? Cumulus clouds are classified as which kind of clouds? They are low clouds. Cirrus is the highest. So the correct answer in this case is going to be A. Now, after this, we come to the types of rainfall. The rainfall which is observed in different areas, in different regions, can largely be attributed to three main types, three different categories. It is basically categorized on the basis of why that rainfall is happening. That is the basis of categorization or classification, why that rainfall is happening. So we'll take a look at this, but before that, we take a break. So let's take a break. We'll be back and we'll take a look at this. And again, another announcement, the reminder of the announcement that we made yesterday. This Saturday, we are going to have an extra session for the session which was cancelled earlier in geography. So we will have the extra session from around 7:30 till roughly around 11:30. We will have the extra session on Saturday morning. That is when we will have the extra class for geography. Okay. Now let's take a break and let's be back in 15 minutes. No, Ankush. We will cover that under convectional rainfall. Type of cloud picture while we are on a break. Okay. This one. Okay. So let's take a break. Let's be back. I told cirrus cloud rarely form precipitation, not condensation. Cloud, if it is there, it will be formed only due to condensation. Otherwise, how cloud will be created? Cloud will be created only due to condensation. Rarely precipitation. Precipitation is rainfall, snowfall. That is precipitation. Okay. A confirmation about the audio, please, if the audio is clear and available. Thank you. So now we start with the portion of types of rainfall or the classification of rainfall. Now, this classification of rainfall is done on the basis of why that rainfall does occur. What is the reason behind occurrence or causation of the rainfall? Because in the hills, the rainfall occurs because of very different condition as the air is lifted up from the ground due to the existence of this hill or a mountain. In the plain areas, there is that rise of air, warm air or the converging air rises up. There's a convection current in place in the atmosphere that leads to rainfall. So, when we talk about this, you have three basic types, that is convectional rainfall, orographic or relief rainfall, and cyclonic or frontal rainfall. Out of these, this is a portion that we will study in much greater detail in the immediately next module. So here we are going to cover it briefly. We will talk about the types of cyclonic rainfall, the types of frontal rainfall, warm front, cold front, everything we will be discussing in a very short meanwhile. Now, the first two, let us try to understand them. Convectional rainfall. So what does that tell you? That there must be a convection current. What is a convection current? We have seen even in geomorphology the existence of a convection current. So what is a convection current? So in the case of a convection current, what do we have? You basically have the rise. This is the entire convection current. Warm air tends to rise up. Now, as this warm air will tend to rise up, now it will lose temperature. It will cool down. It cools down, forms a cloud. Now here, because there is a rising air column, generally you will have a kind of a cumulus cloud formation. Now throughout the day, if the ground gets more heated up, let's suppose, furthermore, this cloud will develop more significantly. You can have a formation of even a cumulonimbus cloud type. And in the evenings, that is around 4 p.m., 5 p.m., you will experience thunder, lightning, and occurrence of rainfall, heavy rainfall. That is the case of a convectional rainfall, where throughout the day, the ground surface gets heated up and the water bodies, whatever water is present nearby, they will be evaporating. So that vertical movement of the air, vertical rise of the air, will eventually lead to condensation at some particular height or the other. As the air rises up in elevation, there will be condensation which will occur invariably. Now, that is what is, excuse me, the case of convectional rainfall. In the equatorial areas, this is a phenomena which is observed on a daily basis. In the equatorial regions, in the small island areas where you have maritime or large water bodies surrounding that area, so that throughout the day you will have a lot of evaporation. So in many of the coastlines also, small islands, for example, definitely you will observe this. So this causes what is also known as the 4 p.m. rain. Every day in the evening, you have the occurrence or the causation of this rainfall. So occurs on a daily basis. Daily basis in the afternoons or in the equatorial areas in the afternoons. Okay, every day. So basically, throughout the day, there is that rise of water and rise of warm air. And condensation will happen at different heights. That is why cumulus. Now, this cumulus cloud develops into a cumulonimbus. So, excuse me. So, rise of air through the day. The day causes condensation and formation of cumulus clouds. By afternoon, this develops into cumulonimbus clouds, causes rainfall, heavy rain accompanied by thunder and lightning. In the late afternoons. Okay, that is the case of convectional rainfall around the equatorial areas, around small tropical islands, also along small tropical islands. Okay. Then we come to the type of rainfall which influences us quite significantly, and that is the orographic or the relief rainfall. Relief features are referred to, or the name is used for various topographical variations and features which exist. So when we talk about orographic rainfall, remember at the time of studying geomorphology itself, we had discussed that anything got to do with orography, orogeny, etc., is associated with the mountains nearby. So, orographic is associated with the rainfall caused because of mountains. So, here, what happens? The same condition that we have been studying till now, the winds, when they face a barrier in the form of the mountains, the wind simply cannot go by the sides of it, that okay, I won't stop, please don't stop my way, I have come from a long distance, I have to go. That doesn't happen. So when the winds face the barrier in the form of these mountains, that is when the winds are forced to rise up. Which side will this one be? The one which is facing the wind, which is this side, referred to as, very good, windward side. And this one, the other one, what is this one referred to as? Good, leeward side. Now here on the windward side, as the winds they come through, they are pushed up. As they start rising up, they will cool down along the way. They will experience cooling, expansion, right? Why expansion? Because they are moving in an upper altitude area where the air density is going to be less. So the air naturally will tend to expand. So it will expand, it will cool down. Eventually, there will be condensation, formation of clouds. These clouds will bring heavy amount of rainfall on the windward side. Very heavy amount of rainfall will be brought over on the windward side. Now, as the wind has passed this region, Let's suppose now the wind has passed this region here. Will this air now be moist, or will it be rich in water vapor, or will it be dry air? What do you think? Very good. So this will be dry air. So dry air will never cause rainfall, and anyway, sinking air will get warmed up. You need cooling to happen in order to cause or create rainfall, right? So this will be the region which will be devoid of any rain. That is why the leeward side of the mountain, they are also what are regarded as rain shadow zone. That is the dry regions not receiving or which do not experience any rain. Do not experience rainfall. For example, if you consider the region of southern part of India, now you have the Western Ghats, which are an escarpment, a steep wall-like formation. Now the western side of the Western Ghats, they receive some of the highest amount of rainfall across the globe, very dense forest. But the eastern side of the Western Ghats, they will be in the rain shadow zone. So there you will have dry conditions. The northern portion of Karnataka, the Vidarbha region of Maharashtra, the region of Telangana, all these areas, even for that matter, the western portion of Tamil Nadu, there you will have very less rainfall. However, you have exceptions. For example, Pune, Nashik, Bangalore, these lie on the leeward side of the Western Ghats. But still in these areas, you experience a moderate amount of rainfall, significant amount of moderate climatic conditions, pleasant weather, substantial amount of rainfall is received. Why? Whereas in the surrounding areas, you don't have that phenomena. But in these regions, you do experience that. That is because Western Ghats in these places, they are discontinuous. They have gaps. Through these gaps, the moist winds from Arabian Sea, they enter into the region of Pune, Nashik, Bangalore, creating the conditions which are adequate or which cause sufficient amount of rainfall. Now, if I ask you a question, basically, when we talk about the Himalayas, Himalayas will have a southern side and a northern side because it is an east to west running mountain or a west to east running mountain, howsoever you consider. Now, which face of the Himalayas will experience more rain in general? Southern slope of the Himalayas or northern slope of Himalayas? Which one of them do you think will experience more rainfall? Very good. Why southern and why northern? Why do you think northern? Or was it that there were two options, you had to pick one? So once I will type southern, once I will type northern, at least I will get it correct once. Westerlies. Where did westerlies come from? It is going to be the southern slope. Why? Because when we talk about the source of moist winds over the Indian subcontinent, let's suppose you consider the Indian subcontinent. Let's suppose. Now, here, if you consider the region of the Indian subcontinent, now the Himalayas are here. The southern and the northern slope. So the moist winds from Bay of Bengal, even from Arabian Sea, when they reach there, they will cause rainfall across the southern slope, not the northern slope. It is in fact this particular feature of orographic rainfall due to which the region of northeastern states, they receive some of the highest rainfall in the world. When we come to the portion of Indian geography, I'll show you with the help of the map also, but today you can take a look at the atlas. In the region of the northeastern states, you will find that the mountains, they are almost in a shape like this. with various different hills here. So when the moist air gets in, it is trapped in these mountains. Unless and until whatever amount of moisture is present, it drops, it will continue to rain. The clearest example of orographic rainfall is the case of Cherrapunji, Mawsynram, and if you consider it, to Shillong. Cherrapunji and Mawsynram, they are amongst the rainiest areas across the globe. Maximum amount of rainfall every year is received in these areas. On an average, annually, these regions, they receive close to around 1140 centimeter, 43 centimeter of rainfall every year. 1143 centimeter of rainfall every year is received in Cherrapunji and Mawsynram. Now, around 100 kilometers away is the city of Shillong. Shillong ends up receiving around 120 centimeter of rain every year. Almost 10 times the difference. Why? Because Cherrapunji, Mawsynram, they lie along the windward side. Shillong lies across the leeward side. So that is how the leeward side will always end up receiving very little amount of rainfall in comparison. Okay. Now, then we come to the next one. Okay, before that, how this can happen that there is rainfall and if the wind blow, there will be moisture in the air. How this can happen that there is a rainfall, okay, and if the wind blows during the rainfall, before the rainfall, or after the rainfall? See, when the winds come over, air naturally has got water vapor. First of all, get that clear. Water vapor is a natural constituent in our atmosphere for billions of years. Now, that water vapor is present in different quantities over water bodies, over sea surfaces. That water vapor content will be much high due to evaporation. Now, as the winds blow, winds are what? The movement of air. So, if the air has got high amount of water vapor content, won't the wind also consist of high amount of water vapor content? They will. So that is why. Okay. Is there flood in Mawsynram due to heavy rainfall? No. Mawsynram experiences a very different scenario. Because of that, you have karst topography. It is a hilly area. So you have many of the underground landforms created due to surplus amount of rainfall. And Mawsynram and Cherrapunji, due to very heavy amount of rainfall, they suffer from a complete loss of topsoil. So that is why there will be many barren patches that you will find. But having said that, one of the absolute most beautiful places that you will come across, you will find many of the underground caves, caverns, etc. Many of them have been closed, shut down, obviously because of the threat perception or the risk associated, because many of the tourists would get lost there. But that excess amount of water flow has created many of these karst topography. Okay, I told about the measurement of rainfall, but okay. Rainfall is measured by the help of a rain gauge. Are we aware about this rain gauge? Rainfall is measured with the help of a rain gauge. So this is kept in measuring or in the weather observatories where a funnel is fixated to the top. And then you have drops. So every raindrop which falls, that rainwater is gathered by this funnel and it keeps on accumulating at the base, at the bottom. Now, this will have markings in millimeters and centimeters. So it is tracked. And accordingly, you get an idea about how much amount of rainfall has occurred. This is your rain gauge. Okay. So basically, the funnel is kept on top so that water doesn't spill out. The drops don't get wasted. All that drop in the vicinity is accumulated. That is the simple construction of a rain gauge. Is that understood, Bhima? I hope that is understood. Now we come to the case of frontal or cyclonic rainfall. What is a frontal or a cyclonic rainfall? So this frontal rainfall is created or is observed in the region where you have the formation of a front, or when you have the cyclonic cells. Till now we have not studied cyclones, so we'll study cyclones very shortly. But wherever you have front, so for example, let's suppose you have, what is a front? The transition zone where the warm air meets with the region of a cold air. Let's suppose this is cold air, lesser in volume, compressed, and this is the region of warm air, expansive in nature. Now this warm air climbs up. Okay, this warm air tends to climb up over the region. Let's suppose they are moving with respect to each other. Warm air tends to climb up. Now this warm air will reach up till here. Now in this area, the warm air will get in contact with the colder region. Thereby, the warm air will start cooling down and lead to the formation of clouds. And that is what brings rainfall. But this rainfall is not created because of the process of convection or because of the process of orographic condition. It is created because there has been a front formation, and on that front, the warm air has climbed up the region of the cold air. Now, because the warm air is in contact with the cold air, that is why you will experience that at the zone of contact, there will be cooling, saturation will be attained, eventual condensation and cloud formation, and rainfall will occur. So that is the case of frontal rainfall. We will study much greater detail about the frontal rainfall very shortly. Now, after this, we come to the fog formation. Now, fog. Most of us have experienced this. Now, if you take a look at the definition of it, definition simply says that fog is a cloud which is formed near the ground surface, because the process of formation is one and the same. But if you have to understand it in simple terms, when condensation happens near the ground surface, that is fog. So in the case of fog, if ever you have witnessed, seen, or experienced the fog, what do you observe? You have many tiny droplets of water, very, very tiny droplets of water hung into the sky, hung in the air near you, isn't it? That can happen only because of condensation. Now, condensation means the temperature needs to fall quite substantially. Temperature drop has to happen, drastic temperature drop has to happen, only then it will be created. So that is why if you have sudden cooling near the surface or significant cooling near the surface, where the air near the ground becomes very cold, that is when condensation will occur. That will lead to a kind of a fog formation. So fog is a cloud with its base at or very near to the ground surface. Okay, or a cloud that touches the ground. Simple words, condensation happens in the air on the ground surface. Okay, condensation occurs near the ground surface. Now, why that condensation occurs? Under which condition that condensation occurs? Based on that, we have classification. We will study that. So, fog shows up when water vapor or water in its gaseous form condenses. There's also something which you hear as mist, mist formation. Mist is also very same as the case of the fog. Both are same. The difference between them is the size of these condensates, the individual water particles which get created, the individual condensates which get created. That is the differentiating factor. So when you talk about mist, so it is a collection of small droplets of water suspended in the air, just like fog. The difference between mist and fog is that mist contains more moisture than fog. How? Basically, each nuclei in the case of the mist, the condensate, contains a thicker layer of moisture. So each of this small condensate, when they are slightly larger in size, you observe a mist formation rather than a case of a fog formation. Now, when we talk about the types or the classification of fog, that classification is done on the basis of why that condensation has happened, where that condensation has occurred. So accordingly, you have the radiation fog, you have the advection fog, you have the steam fog, the upslope fog, as well as the valley fog. These are the major types of fog. So radiation fog. This is something that you all of us are experiencing presently in the present day during the winter months. So here, what is that radiation fog? What is this radiation about? So this happens when the ground surface loses its heat during the long winter nights, when the ground loses its heat, loses its temperature. How will the ground lose its heat? With the help of terrestrial radiation. So that terrestrial radiation is what leads the ground to lose its temperature. The air near the ground surface will also lose its temperature. It can reach saturation, it can cool down furthermore, lead to fog formation. Okay, so ground loses heat by terrestrial radiation. Radiation the air in contact also cools down. Condensation occurs. Formation of fog. Now, this scenario will be experienced when? Winter nights, when the ground has to become so cold that air above it starts condensing. Winter nights, because the winter nights are longer, that is when the loss of heat can be very prolonged. So, the long winter nights. But along with that, clear sky. I hope we are aware of the fact that when you have clouds, we have talked about it previously as well, that when you have cloud cover, these clouds, they will re-radiate back the terrestrial radiation and they will reheat the ground surface. For condensation to happen, you need the colder ground surface. That is why cloudy nights, they are not very good for the either the dew formation or for the fog formation, because the clouds will re-radiate back this terrestrial radiation. So here, when we observe this radiation fog, this is generally observed in long winter nights with clear sky. Very light winds, calm conditions, or very light winds, light breeze rather. Because if there's a strong, very strong wind movement, the droplets of water will be carried away by the wind. You won't be able to observe the fog anymore. Right, that is why even nowadays, if you are observing in the region around you, you would be observing daily fog formation. But let's suppose it is very cloudy one night. Let's suppose it has rained heavily, or it is, in fact, in the case of rainfall, there will be easier condensation. But let's suppose there's a very strong wind movement in the night, you won't observe the fog formation. So you need calm conditions. So what happens? So basically, the ground loses heat because of that terrestrial radiation. Terrestrial radiation. Now, when the ground loses heat, let's suppose this is the ground surface. As the ground surface continues to lose its heat, the air above it also cools down quite substantially. the air above it also cools down quite substantially. So when the air cools down, cooling down, when that happens, what does it lead to? It will lead to saturation and eventual condensation. That is where you will observe the fog. Okay. Now, observe this. If you have not noticed it till now, observe this from tomorrow itself, because present conditions are such that fog formation would be common in almost majority of the parts of the country throughout the year. By the way, today is 4th of January. 4th of January marks an important date in the movement of Earth along its orbit. Can you think about a particular reason why 4th of January is special in terms of the movement of Earth along its orbit? Very good. It is not winter solstice. It is perihelion. Today is the day when the planet is closest to the sun. Okay, so these things, keep marking it out. You will never forget it then. If you relate it to your day-to-day lives, that is when it basically becomes very integral and you don't tend to forget it. So this is, no, it is not the longest day. So that happened in on 21st of December itself. That was the case of the winter solstice. It is basically when the planet is closest to the sun. It is the day of perihelion. Now here, no, the distance reduces to around 147 million kilometers. In aphelion, it is around 152 million kilometers. Now, very good, yes. Now, observe one thing, that you have this fog formation. Let's suppose you have this fog formation. Now, this fog is something that you will start observing generally late at night, unless and until it is very cold. So generally after 11, 12 p.m. at night, you will start experiencing this. Early in the morning also it will happen. From around 7 a.m., 6 a.m. onwards, when the sun rises up, the fog starts to thin out. But have you ever observed that from where does the fog start to thin out? From the bottom or from the top? Generally what happens, the next morning when the sun rises up, the ground gets heated up. Again, some amount of heat is received. So when the ground gets heated up, it will start warming up the air immediately above it. That is when the saturated air obviously will reach unsaturation and the fog will start dissipating from the bottom up. Slowly and steadily, the fog will disappear. That is why in forested areas, for example, in forested regions, you won't experience the fog to disappear so easily from the ground. But in the case of roads or the open areas, the fields, for example, you will observe that it starts disappearing. Why? Because within the shadow of the trees, heating will take time. That rise of temperature will take time. But in case of black asphalt roads, that rise of temperature happens very quickly. So is the case in urban areas. In very dense colonies, etc., you will observe that it starts lifting up by around 6, 7 a.m. in the morning. It starts lifting up. If there has been cloud which has developed overnight after the fog formation, then the sunlight will be delayed. In the sense, the appearance of the sun rays on the ground surface will be slightly delayed. So the fog can persist for a longer duration in that case. Okay. Now, that is the case of radiation fog. Now, then we have the advection fog. Advection fog basically created due to the process of advection. Advection is the horizontal movement of the wind. So, what is this advection fog? So let's suppose you consider the case of a warm advection. Let's suppose you consider warm advection. Now warm air is moving towards a colder region, let's suppose, for example westerlies. Now as they move across the colder surface, this warm air will also lose temperature, isn't it? This warm air will basically become cooler and cooler, will reach the level of saturation and eventually cool down furthermore, leading to condensation to occur. So here the condensation occurs because the warm wind gets in contact with the colder surface. That is why condensation will occur. So that is the case of advection fog or a fog formation due to the process of advection. Okay? But why fog is more dense in open areas? I have seen in highways at morning. Think about it. For a brief moment, apply your logic. We have discussed this, you would know the answer. Why is it that there will be much more fog formation in the early in the morning, 5 a.m., 5:30 a.m., or 4 a.m.? On highways, you won't be able to see anything. But in the case of buildings and colonies, you will still be able to figure out your way. What might be the reason? Can I say that in these open areas, okay, let me see the kind of responses I get. They lose heat very quickly. Good, Godavari, very good. Land cools and warm fast. Do you mean urban heat islands? Yes, a sort of that. Heat loses quickly, yes. Basically, when you have open areas, there retention of heat will be less. The terrestrial radiation lost will be very high. If you talk about habitations or buildings, there some amount of heat will be retained, will be trapped. Very little amount, but some amount will be retained. That is why if you observe in, I don't know, in whichever city you are living in, every city has got that kind of conglomeration of buildings with narrow bylanes, etc., very narrow lanes. Those regions never get impacted by fog. Regardless of how much fog it is, you will be able to walk through the lanes easily. When you come to the open road, it becomes foggy. Why? Because in those small areas, heat is retained by the walls of the buildings, the construction, etc. But in the open highways, there is nothing to trap that heat. It is lost directly. That is why it cools down very rapidly. Okay. In Delhi, there is fog almost all day. Is it due to land is cold or any other reason? Delhi experiences radiation fog, as simple as that. Now, in the region of Delhi, and as is the case with the entirety of northern plains as of now, you will observe that basically there is multiple factors. One of the factor is also pollution. The other factor is significant amount of some amount of cloud coverage is there. Thin cirrus cloud and other kind of alto cloud formation is there in Delhi. During these seasons, there is formation of that cloud. Now, what that will do is that will block the morning sunlight. And when you have the blocking of the sunlight, that will basically mean the surface becomes cooler. Understand one thing, when we talk about the clouds, for example, there is a different action of the cloud. For example, if you have low level clouds, these will block the sunlight always. So low level clouds will cause cooling. They will cause cooling. When we consider high level clouds, middle or high level clouds, altostratus, cirrostratus, etc., these won't be blocking the sunlight so much, but these will be blocking the terrestrial radiation. So high level clouds cause a bit of warming. I hope this is not very confusing enough. Clouds, they cause warming. Okay? That is the reason why you will observe that in the case when you have low level clouds, there is blockage of sunlight, the ground becomes colder and colder. And when the ground becomes so very cold, it is unable to gain heat. So the air above it will also be cold. There will be continuous fog formation. Having said that, even during these days and even during these conditions, if you visit the open roads in the central portion of Delhi, they are not that foggy during 12 or 1. Right. Long distance visibility is reduced, particularly during this season, also because of smog, pollutants which develop. That also plays a major factor. Okay. Now, then we have one of the most unique features or one of the most unique fog formation, that is what is known as the steam fog. The name in itself, steam fog, is given because it appears as if steam is rising up in the water. But clearly, that is not the case. The fog formation gives you that appearance. So, this is formed early in the mornings and very late at night, basically, above the water bodies, small water bodies like lakes, ponds, even larger rivers. There also you will find this. In these seasons, if you have a larger lake nearby you or a larger river near you, you would observe the formation of fog above it. Right. So that is the steam fog. It appears as if the fog is rising from the water surface. That is the steam fog. So here forms above small water bodies like lakes, ponds, rivers, even sea sometimes is where you will find in the coastal areas. Coastal areas of marginal seas. If you have not witnessed this, try to look at the nearest water body wherever you are living early in the morning. 6 a.m., 5:30 a.m., you will observe this fog. So, why does that happen? So, let us understand this. So, here, let's suppose this is the water body. Let's suppose. Now, here you have the land area. Excuse me. So, here you have the land area. And here you have the water body. Okay. Now, late during the night, which will be colder? Late during the night, early in the morning, which will be colder? Land or water? Very good. Land will be colder, right? So, movement of winds will happen from land to water or water to land. What do you think? Movement of wind, land to water? Very good. We are talking about small lakes and ponds also in this case. Now, water body will experience some amount of evaporation always. Some or the other amount of evaporation will continue to happen. Evaporation means that water droplets, they are rising up, or rather water vapor is rising up, isn't it? That is evaporation. Water droplets or water vapor is rising up. Meanwhile, you have cold winds coming from the land. Cold winds. Now, when these cold winds, they encounter this water vapor, which is rising up from the water body, almost immediately, there will be condensation because water vapor will experience that cold temperature immediately. There will be condensation. Now, the condensation which will happen in a kind of a shape that the vapor was rising, right? Like the vapor was rising. That is how the condensation will occur. So, in this entire area, you will observe a kind of a fog formation, somewhat like this. It will appear as if it is rising up from the surface. So, that is the case of a steam fog. In these months, particularly in our country, in these months, when the land becomes very, very cold, the nearby water bodies will experience this formation. Okay. Now, suppose in a foggy area, fog is generally formed on a large water body also. Yes. Then we call it steam fog or just the extension of radiation fog. So, in the case of the sea, when you have fog formation, let's suppose in the polar regions, you will have radiation fog. But sometimes you have the warm ocean currents and the cold ocean currents meeting each other. So that is where you will have the kind of the warm winds and the cold winds associated with it also meeting. So that is where you will have the kind of a sea fog as it is referred to in certain areas, but in certain areas, steam fog is also referred. That is a disaster for navigation. Does it happen? Does this phenomena occur at River Ganga in certain places where the river is very broad? Yes, it does. Okay. But in majority of the river systems, you will observe the radiation fog to be prominent one. Now, then coming to upslope fog. What is upslope fog? Nikhat, here cold winds are moving towards water and fog formation is due to the winds. Can it be advection fog? No, because you don't have advection is generally a term used for large scale movement of winds, just like onshore and offshore. So large scale and over a large distance movement of wind, if it occurs, that is when you refer to the name as advection. Okay. Now upslope. Now early in the morning, sometimes when you move across the hills or the mountains, you experience that you won't be able to see the hilltop, right, or the top of the hill. Basically, it will be foggy. Now, what happens is that you have slight movement, very slow movement of wind, what is known as the orographic uplift. If the wind moves very strongly, it will rise up from the mountain form, lead to the formation of clouds. But if the wind is moving very, very slowly, it will lead to cooling of the wind and condensation along the way, and you have the formation of upslope fog. So upslope fog or a hill fog, it forms when winds blow air up a slope. So you have slow movement of wind, very slow movement of wind. That is what creates or causes upslope fog. Then you have a valley fog. Valley fog, which oftentimes covers the entire valley and the visibility reduces almost to zero. Now, that valley fog can be very dangerous. It claims many, many lives due to the navigational disasters and the air disasters. For example, the unfortunate helicopter crash, which happened um, around a couple of years back, where we lost our first chief of defense staff. I hope you remember that event. So, that again was created due to valley fog. So, why is it that valley fog is created? What is the reason? The reason is very same as we observed in the case of valley inversion. The reason is very, very same. So, here, basically, in the valley areas, Uttarakhand experiences this, Arunachal experiences this. You have many, many casualties claimed due to this valley fog. So, Let's suppose you consider this valley area. Now, generally, the winds at the top or the air at the top of the mountain is going to be cold. Here you will have cold and heavy air. Now, this at the valley bottom, you will still have comparatively a warmer air. Now, this warmer air is going to be lighter, colder air is going to be heavier. So, this cold air is going to sink. And after some time, you will be able to foresee a situation where this entire portion of warm air gets lifted up. And you have the cold air which grips this. In this entire area, you will have the cold air which would have sunk, which would have displaced the warmer air. So the warm air would be lifted up, would come maybe here. That is where the warm air would be lifted up. Now, wherever this warm air is in contact with the cold air, there will be condensation. And plus, if we are talking about, let's suppose, a colder condition or a colder climate, from top also this warm air will condense. So that is where the entire valley that experiences the fog. As you will observe here at this point of time, you cannot even figure out what is the bottom of the valley. You cannot figure out where the bottom of the valley is, right? So that is how you have the formation of valley fog, always and oftentimes associated with the condition of valley inversion. Okay, so that is the case. Incoming cold air is also the mountain breeze. Yes, that is true. Now, these are the questions that we had already discussed yesterday. Now we come to the next module, basically here. Okay, we'll do one thing. We'll study from some portions here itself. So, now we'll start with the portion of air masses and cyclones. Just a moment, guys. There appears to be a technical issue. So, just wait for 5 minutes and we'll 2 to 3 minutes and we'll be back. Okay, just wait for 2 to 3 minutes. Let's get this sorted out. A confirmation about the audio and the video, guys. If the audio is clear. Okay. So we'll do one thing, and I hope that you guys are comfortable with this. So the portion of air masses and cyclones as of now, we will use the blank slides as of now. We will cover as many topics as we can with these blank slides itself, because presently it is no point of ending the class and loading the new PPTs. Tomorrow, when we come, we will initiate the discussion from where we have left off, and I will show you where in the PPT what has been written. But then we will move as per the requirement of the PPT itself. So, are you comfortable with the blank slides? Is there any issue? Presently, there is an issue with the PPT, Aryan. That is what I took the break about, and I wanted to check it up. But it will consume some amount of time to end the session. Many of you will have to rejoin the session. I don't want that kind of a discrepancy created or that kind of disruption created. So I hope you are okay with this blank slide approach only for the remaining portion of the session. Okay. Dictate something, dictate something important. The greed comes in almost immediately. No, dictation is not going to happen. Understanding is something I'm going to rely upon. Now, here, basically, Pile Valley fog is basically when the cold air from the mountain top simply sinks at the valley bottom, lifting the warm air upwards. The warm air in contact with the cold air will lead to condensation of the warm air, formation of the valley fog. Now, when we talk about this air masses and cyclones, this is going to be very relevant both for the prelims as well as mains examination. If you take a look at the average or the distribution or the trend of questions, both in prelims and mains for the past 15 years, questions have been asked substantial amount and substantial number of times. So here, the portion relevant for your prelims. I would not suggest anyone to go for GC, but if you want to study it, you can. But I would suggest that NCRTs are freely available online. Go through it. Or I hope everybody has got pre-recorded lectures for geography. Pre-recorded lectures, they are also more than sufficient. So if you don't want to study the NCRT, even that is more than sufficient. Do look at the pre-recorded lectures. Some of the portions we have included really good animations there, which will be very helpful to you guys. So try to do look into it. Now, for the prelims, basics of air masses, types of fronts, formation and conditions, then after that you will have cyclones, cyclones, temperate and tropical. Temperate, that much attention is not paid, because temperate cyclones, they don't influence India that much. But when we talk about tropical cyclones, this is very, very important. One of the pet areas of UPSC, both for GS as well as optional. So here, formation, conditions required, and features. Whereas here, you get the basics, which can be asked. Now, in the mains examination, Twisha, that should be the ideal approach. Attend all the classes, revise it with the books. Till that point of time, revise the classes as many times as possible. In the mains examination, air masses and influence on climate. Then formation and naming of tropical cyclone. Then formation of temperate cyclone, because both of them are very different. Types of fronts and weather associated. Types of fronts and weather associated. It is enough, Megha. Nancy, if you are able to make your own notes, that will always be beneficial. Ritika, write a mail, send it to us. Now, here we start the discussion first of all with the concept of air masses. What is an air mass? Now, in simplest of the terms, air mass can be defined as a homogeneous air over a large area. What is homogeneous? That is similar property of temperature, moisture, density, that is similar and spread over a large area. Maybe if you observe the region over the Eurasian continent, it is a large area, right? So it will have a kind of the property of air. If it is uniform, it will be an air mass. Air masses, they are not of small formations. These are masses of air, or in a way, large amount of air having a homogeneous property. So if I were to write the definition of it, so these are large volume of air spread having a uniform property of temperature, humidity, density, etc. That is an air mass, which is spread over a large area. It covers a large area spanning hundreds or even thousands of kilometers. Okay. For example, let's suppose if you go to Mumbai, air is moist. If you go to Nasik, maybe air is dry. That in itself cannot be considered as an air mass, right? But air, the quality, the property of air will vary. For example, if you tend to go to a desert area, let's suppose a desert region, Jaisalmer, right? Now, there, the air will be particularly dry. You will feel that dryness because of lack of moisture, and it will be hotter. If you go to Leh Ladakh, the air will be dry, but it will be cold. If you go to Chennai, Kolkata, Mumbai, Trivandrum, Goa, air will be warm and moist. So, air in different areas are exhibiting different properties. Now, why is it so? Why is it so that the air over Jaisalmer will indicate a different property as compared to the air in, let's suppose, Indian Ocean? That is because of the influence of the surface. So if the air or an air mass spends a considerable amount of time over a particular area, it gains the property of that particular region. We have seen yesterday when we were talking about Lu that when you have the formation and the movement of Lu as it crosses the region of the Thar Desert, that those winds become warm as well as very dry, isn't it? So here, when you have when the air or the air mass, don't get confused by the term mass here, guys. Air mass here simply talks about the fact that you have a large mass or a large chunk of air. That's it. When the air mass spends significant amount of time above water bodies or above any surface, it tends to gain the property of the surface. Right? For example, air above the desert is dry. Desert is dry. Air above tropical oceans. Tropical oceans is warm and moist. Is warm and moist. Now, such surfaces from which the air tends to gain its property, these surfaces are regarded as the source regions. Okay, so they are regarded as the source regions from which the air has gained its property. Now, the classification of air mass, the nomenclature is also there. That is purely driven by the source region. For example, the air over region of Antarctica. Now, that air over Antarctica will be very cold, right? The air over the region of, let's suppose, Arctic, that will also be very cold. So, like that, you have the different property of the source region allocating the different names and nomenclature. So, when we talk about the naming of the air mass, it is done based upon the naming of the source region. Air mass done on the property of source region. So here, basically, you have to understand that in different areas, air will have a different property. So the first things first is you classify the air whether it is continental or whether it is maritime. Continental means what? It is over a land area. It will be dry in nature. Maritime means what? It will always be moist in nature, right? So the first thing that you do is basically continental or maritime. You name the air mass. In case it is continental, you attach the term C. In case it is maritime, you attach the letter M. Continental air, dry. in nature. Moist will be the maritime. Now then, the air masses are divided based upon the latitudinal extent also. For example, over the region of the water bodies at equator, you have the name E, equatorial air mass. E is given to equatorial air mass. Right? Above water bodies around equator. So, above the water bodies around equator, be it the region of Indian Ocean, be it the Pacific or the Atlantic, the air will be named by what name? It will be named as ME. You will not have a continental equatorial air mass. There is no such continental equatorial air mass. Why? Because at the region of equator, and listen to this very carefully, at the region of equator, you will have the consistent amount of rainfall on a daily basis. And also, if you observe the region of equator, you don't have much of the landmass. Some area in Africa, the thinner portions around Congo, some areas in South America and Southeast Asia. That's it. So equator doesn't have much of a landmass, and whatever landmass is there experiences such frequent daily occurrence of convectional rainfall that the air is anyways moist. You cannot attach the term sea here because sea or continental air mass is associated with dry air conditions. That is why you will only find the denomination as maritime equatorial, not continental equatorial. But that is the case only with the equatorial air mass. Then you have T, that is for the tropics, air mass in tropics, right? So around 20 degree to 45 degree, you will have 20 degree to 45 degree north and south. That is where you will have tropical. So this will have the nomenclature. If it is above the water body, it will be maritime tropical. If it is over a continent, it will be continental tropical. Then you will have the polar air masses in higher latitudes. 50 degrees north or south to around 70 degrees north or south. That is where you can have continental polar, you can have maritime polar. Siberia will have continental polar, right? North Atlantic will have maritime polar. Now, for example, the region around Arabian Sea, Bay of Bengal, maritime tropical. The region over central portion of India, continental tropical. Okay. Then you will have Arctic and also Antarctic. Arctic region, AA, refers to Antarctic region. Now, Arctic is an area where you will generally find in the region of the Arctic, there is a very significant influence of the landmass. Land masses are present very close by. Arctic, even that ocean, is basically the frozen ice over the region of the Arctic. So it also exhibits some of the continental properties. So the name associated is always continental Arctic, CA, and Antarctica is a continent, continental Antarctic. So these are basically the 7 different types of air masses which are present across the planet, you have the classification of the air masses in these various different 7 types. They are named based on the property of the source region. Whatever is the property of the source region, accordingly, they are named. Now, here, I want you to focus upon something now, which we have discussed in the case of permanent wind movement also. So basically, let's suppose this is the planet Earth. Let's suppose this is your equator. Now, you will have the westerlies moving from around 30 degrees north to around 60 degree. Westerlies will be an example of warm advection or a cold advection. What do you think? Very good. So westerlies will be an example of warm advection. Tropical air is what they are bringing, right? Meanwhile, from the polar areas, you will have colder air, which is coming in. Now, will they be meeting at the same line, a straight line? No. In certain areas, you can have the colder air which will come further southwards. In certain areas, you will have the westerlies which will go further northwards. It will vary. It will vary upon many factors. Now, wherever these air masses will meet, there will be a zone of transition. In this entirety of the area, there will be a zone of transition between the warm and the cold air mass. That zone of transition which gets created, that is what we refer to as a front. That is what is known as a front. Rachel, you can ask a question. If there is a question, you can ask it. So what is a front? Front basically is zone of transition between air masses of different temperature, moisture, or simply put, different properties. Okay. Is it only the land will change the property of air? No, water body also. Maritime air masses, they are very moist. If ever you have been to a kind of a boat in the sea, you will feel that moisture in the air. The air will be very damp, right? So that is where over the maritime areas, the air is always very moist. Okay. Now, how is this front created? What does this front look like? And what is the formation of it? So why is the front created in this case? In this case, as we see, frontal formation is occurring. Why? Because the warm and the cold air masses are coming head to head. It is not going to be the case that if you have a cold air mass, let's suppose here you have the cold air, and let's suppose here you have the warm air. They are spread across a distance of many hundreds and thousands of kilometers, so it will not readily mix with each other. Depending upon which has got the power, either the cold air will enter into the warm air territory, or there will be the vice versa movement. The warm air will push into the cold air territory. But there will be eventually some movement or something which will happen. Let's suppose the air does not move at all and stays like this. Cold air and warm air head to head, they stay like this for around 21, 25 days. or even after 2 weeks that starts to happen. That is when slowly and steadily they will start to intermingle and the front formation will be lost. So as long as there is this zone of transition, that is a front. Formation of a front or the birth of a front will occur when you will have air masses of different properties coming in front of each other. So formation of a front is known as frontogenesis. Is formation of the front. Now eventually there can be the death of the front also. Let's suppose the cold air mixes with the warm air, neutralizes eventually. There can be, if it neutralizes, let's suppose the cold air is in front of the warm air, there is no movement for 14, 20 days or 2 to 3 weeks. They will start gaining each other's properties. So in that case, we can say that the front has disappeared because now there is no longer that zone of transition. As long as there is that zone of transition, there is that front. But when that zone of transition gets diluted, we can say that the front has come to an end, the front has dissipated. So that dissipation of front is known as frontolysis or the death of the front. Dissipation of the front. So, if I ask you a basic question here, if when is it that front formation will be observed more prominently or more frequently? When the temperature between these air masses, the difference of temperature between the air masses when it is high, or when the air masses are close to each other's temperature? When is it that front formation will be much more clearer, much more demarcated? When the difference of temperature between the air masses is very high, or when the air masses indicate similar temperature? What do you think? Very good. Beautiful. Whenever the difference in temperature is very high, very staggered, that is when this zone of transition will be very prominent. That is when it will be much more effective, it will be much more prominent also. So frontogenesis is observed more frequently and prominently if the difference of temperature between the air masses is very high. So when will it be observed? During the winter or during the summer season? When is it that frontogenesis will be observed? Whenever there is a greater difference of temperature between the tropics and the poles, that is when it will be observed. So during which season is there a greater difference of temperature between the tropics and the poles? Summer or winter? Very good. No, not very good. Okay. So basically, let me give you the articulated table. Winter, summer. Tropics, poles. During the summer, in the tropics, the average temperature is around 35 degrees Celsius. roughly around 35 degrees Celsius. On an average, we are considering around the region of poles. The temperature during the summer month is -5, -10 degrees Celsius. Let's assume -5 or -10. Right. What is the difference of temperature in this case? All the Aryabhattas of the class. Good. Difference delta T is 45 degrees Celsius, isn't it? Now, in winter, in the tropics, the average temperature ranges between 20 to 25. Let's assume we take the case of, let's assume 20 degrees Celsius. In the region of the poles, it can be -40, -50 degrees Celsius. Let's assume -40. What is the difference in temperature here? 60 degrees Celsius. Very good. So, in which season now we can say that frontogenesis will be very common? Winter or summer? What do you think? Very good. Always in winter. That is why this frontogenesis is very common and is very frequent. Frequent front formation will be observed during the winter months. Okay, so the formation of front is much more predominant during the winter months. Now, then we move to the types of fronts, or we'll do the types of fronts tomorrow itself. Today, I will give you some map pointing. GIB, just a kind of a warning for you. Not a warning, but something that you should know about me. When you start saying time up, I always get a tendency to teach for more 20 minutes. If you don't say that, I might end up the session before time also. So the more the people remind me that the time is up, I tend to stretch it up. So please, if you want the classes to get over early, this is the last thing that you should do. Okay. Now, map pointing. So have we marked the rivers in the various different continents? Have we marked the rivers? Have we done the map pointing for that? No. Okay. Some are saying yes, some are saying no. I don't think we have done that. Now, before anything else, I want you to look at the portion of Pacific Ocean, eastern part of Pacific Ocean, and western part in detail. When we say western part of Pacific Ocean, we mean the region around Australia, Indonesia. I want you to take a look into the countries there. Eastern part, I want you to take a look into the countries there. And same with the Indian Ocean. This is something that needs to be done necessarily before tomorrow's class. Now, certain rivers. St. Lawrence, Rio Grande. In which continents are these situated? Then Mississippi, no, it is not related to Rio Earth Summit. Rio Grande actually forms the border between Mexico and US. St. Lawrence forms the border between Canada and US. Both St. Lawrence and Rio Grande are used for internal trade and internal navigation, where you have movement of cargoes, goods, etc., taking place through the river movement. Same is the case with Mississippi. Okay. Then also locate Missouri, Colorado, then Orinoco, Parana, Amazon, etc. You would all have learned from your childhood days, but still, I will give you that joy. Then, after that, Rhine, Rhone, Danube. Also, look at where do they drain, where do they empty their waters. Dnieper, Dniester, Volga, Don, Niger. All these are rivers. Volta, then after that, Orange, Congo. Here also look at White Nile and Blue Nile. Then Murray, Darling. Then in Asia, just locate Tigris, Euphrates, Mekong. Okay. So basically, this is in North America. These will be in South America. I am simplifying it for you. These will be in Europe, along with these two, will be in Europe. Then, okay, no. Here, instead of Niger, let me write here Nile. And then locate Niger separately. These will be in Africa. These will be in Australia. These will be in Asia. I want you to open up the atlas. If not being able, physical map of the world, you will find this. You'll find these rivers. Look at the regions around them. In the physical map, you are able to figure out whether it is moving through plain areas, whether it is moving through hilly or the mountainous areas or the plateau region. Just look at the countries, the regions where they end up moving through. That is the amount of idea I want you to gain from this. It will hardly take you 20 minutes. And that too should be explorative because many of these names you might not have heard before. Okay. So UPSC is known to ask some factual random questions here and there. When we do the mapping portion, if I suddenly start picking up these names that look, this is where river Rhine flows, this is the Rhine Valley, it won't make any sense to you at that point of time. So that is why do this, locate these areas and the regions where they flow. So that is where we will. Pacific Ocean on map is confusing. Why confusing? Just look at the external extremities of the Pacific Ocean, where Pacific Ocean is. So we meet again tomorrow. and we carry on the discussion about the fronts and the cyclones and the portion of the Enzo cycle, for which I want you to study these, look at these maps carefully. Till that point of time, take care of yourself. Goodbye. Thank you. Barkat, locate this. This should stay in your memory. You should repeat it multiple times.